Yes, sir, we can.
You are ready, no?
Okay, I think there are participants, enough participants here. All right, good evening, everyone. Nice to see you again today. I will start sharing my screen and
बरं आम्हाला वेलकम बोलायचा चान्सच नाही दिला का?
sure. Go ahead.
It's okay. Welcome, welcome. So this is our ninth day of, and we have with us again Pawan using autonomous car. Let's see how we like his car. So Pawan, share your screen start without waste. Pawan sir,
Yeah, I hope now I'm audible. I think I started speaking without unmuting myself. So, is it audible?
okay.
Good, good.
Yeah, yeah.
So, do let me know once my screen is visible.
Yes, it is. And we are inside the car.
Okay, great. Yeah, that's something I wanted all of you to start with. Um, so today you are seeing an application where um, we have this car which is following a lane and try to stay within this lane. And today we'll see some of the case studies like this, how an application like this can be built, how we are going to use something like deep learning algorithm to implement an idea of this kind, and so on. So here you can clearly see that we have a vision as an input, and clearly over here this camera is capturing the images, understanding the lane of on this road, and try to follow that. And it is also observing the objects in front of this at a given point of time. Okay, so this is the kind of application that we will be working with today, and we will see how we can build something like this from scratch. Um, I assume that 2 days ago there was a session done by MathWorks, done by Amit Kamath and I think Praful Pai. Um, and that during that session you saw the deep learning workflows, because that's what I mean, people at MathWorks in deep learning sessions do, and when I used to do that until say 6 months ago. And I will be standing on top of what Amit has done and will demonstrate how these deep learning algorithms can be brought inside autonomous vehicle application, and you can start building an application for um autonomous driving over here. Okay, so let us stop the simulation. And in today's session, um, one important disclaimer is that I will be going on pause at times because I'm working with quite heavy simulations, and there will be instances when um, the simulations will go slow, and that is the reason I have to slow down parallelly. But I will ensure that some discussion is happening when the simulation is in progress. Okay, so you just now saw a simple simulation of lane following, and um, let me just show you a few things for getting started, so that you will be able to understand what kind of applications we are working with. So yesterday, do you remember that we designed a very simple car model uh, using a first order differential equation? So today here you can see that that car model is now the advanced version of the car model that you saw yesterday. And let me put this. So here you can see that this is a much complex vehicle dynamics model. In fact, here you can see this kind of dynamic model is uh, as good as, say, equivalent of a bicycle model, which has a definition in SAE, which is J670, which is popularly used in the automotive industry for designing algorithms for, say, autonomous driving vehicles. And what we will do today is the AI algorithm that is designed. It will generate some control signals eventually, and those control signals are given to this virtual vehicle, and then you will be able to see what kind of say maneuver this particular vehicle is capable of doing over here. Okay, so all right. So are you excited for the today's discussion? This is a new kind of application that we'll be looking at, and yeah, let's see some case studies. As the title of this session is AI case studies, we will see a lot of case studies today, which will talk about how deep learning algorithms are used in this kind of environment, AI environment, and all the discussions that I will have, I will try to gauge if we can fit it in the 2 hours time zone or say time frame that we have, and it will be sparse discussions of various algorithms that you have seen yesterday, or say sensor that you have seen yesterday, and how they will be working with an end application. So let's do a deep dive. So I would like to start with say deep learning itself, how we can detect some objects on a road. Okay, so let us see one of these applications over here. Okay, good. So if you are seeing this kind of screen for the very first time, this is a live script. Live script is like a MATLAB program that you used to write, but it is more interactive. You can write your text, you can add some say controls or tasks in your live script, and make it more interactive. It is similar to Jupyter Notebook if you are say Python user. It's just that this one is the way MathWorks demos are shared, and actually you can take a look at this applications directly from MathWorks documentation. So we'll see first application. How do we train a deep learning vehicle detector? Okay, and this complete application is based upon camera input. As we discussed yesterday, that in your sensors, there's a high chance that in current say generation algorithm, you won't be able to get the best um, technology, or say the best output from your camera because of the technology limitation. Although we might be able to design the best of the best say algorithms, but let us say in future there will be autonomous vehicles which will be capable of driving itself only using vision input, and say camera as the only sensor. It won't require radars and lidars, but that's in future. So I'm just focusing on images because that's the kind of application you have worked with. So for this one, we will be having collecting data from around our ego vehicle. Ego vehicle. Can you even recall the definition of ego vehicle yesterday? So that's the reason why I had an elaborate discussion about all the terminologies. So ego vehicle is the vehicle which we will be controlling at the end of the day, and that's what we are considering right now. That is it is the self car. Thanks, Chidna ma'am. So as you can see or read in the description, it completely depends upon the ability of the vehicle to say detect all the obstacles, and say vehicle and track its position in order to say do a lot of tasks around it. For example, if there is about to be an accident, you can actually have a warning about it. Or yesterday we saw some application like cruise control, or just now you saw an application of lane keeping. All this requires or there's a possibility that we can use deep learning neural or say neural networks to actually take those decisions. And today we will be seeing some pre-trained neural networks, that is this one, vehicle detector faster RCNN, and vehicle detector ACF. I will actually show you how these neural networks are arranged for quickly building this application. um, One important disclaimer is that this neural network that we have trained might not be the best neural network for every application that we have, but there is a high chance that you can use this as a reference, and use something called as a transfer learning for reaching from point A to point B. That is uh, using an existing network and then retraining that network as per your requirement using the limited data set, and say deploy it in the car at the end of the day. Okay. Also, you can say build a neural network from scratch, train it, and still use it for your end application. So, does anyone recall or have you heard about transfer learning before? What are the challenges of transfer learning? Just curious to know about that. Any answers? Any guesses? All right. So yes, reinforcement learning, Jayashree ma'am, it might be it is actually something else over here. Reinforcement learning is a situation where you actually simulate it, understand whether the system is performing as per the requirement within the given constraints, and then you learn from your past mistakes and keep on training your system in such a way that it will do take the right action, and once the right action is taken, you will reward your system, and accordingly it will keep on learning the best things to do, and eventually say your system will be capable of driving itself. So it's a contemporary, or say um, something on the same lines with PID control and something like that. Okay, one algorithm applied to another problem statement. Yes, good ma'am. So we won't say algorithm, but we will say a neural network which is already trained using millions of images, and then we will say take the features which is trained in the existing neural network into our system, but we'll retrain it to fit our requirement. Okay. I hope everyone is able to understand the things that I'm talking about. I know it is a little advanced concept in deep learning, but I hope people are able to cope up with, because of say the training that you had in past few days. Um, Today, I will not train any neural network because, well, we need a very powerful system to do that. But I would rather download an existing neural network which is on Mathos website and start using it for our application so that we will be able to see how that kind of application work. Okay, so over here, to enable, say, using pre-existing neural network, I will use this command false, so which means that I won't be training and evaluating my neural network at this time, but I can definitely show you how that can be done by, say, end of this session. But yeah, we already have a neural network which is already pre-trained for our application. So let us see if I have downloaded that neural network. Um, just a second. So, hmm, yeah, here we have it. So, all right. So, we have now downloaded, already I have downloaded this neural network in my current folder, so I can start using it. So again, as I mentioned, there will be few things that I need to check from time to time in order to make sure that there is no error when I'm executing few things. So yeah, uh, uh, so the data set that we have here is this label dataset which contain around 295 images, and each image contain the instances of a vehicle, and we will be using this dataset for say training at this time, and right now we won't be training it, but I would rather show you how this dataset look like. So let us open our dataset over here. So is it opened? Yes, over here. All right. So here you can see that images are being opened. As currently I'm running a lot of programs. A few things might go slow, but yeah, you can actually see those images which are captured for training your neural network. Today, I will also teach you how we can collect this kind of data. So this data is called as ground truth, and we need to. I have one question for all of you. Um, Whenever you're doing your research, what would you prefer? A data which is say very well labeled, or something which is randomly available and you as an engineer would like to label it individually? What would you prefer at the end of the day? I mean, do you have the bandwidth to train or say label millions of images? Label data, absolutely right. So let us say you have captured hundreds and hundreds of images in from real world. Um, is there going to be an advantage if you have an easy workflow to label all that data for you, an algorithm which will be capable of doing that for you? Will that, do you see that as an advantage for building an application like this? I mean, how many of you love labeling your data? Definitely not me. I don't like that much of task. I know we do a lot of labeling in our day-to-day life, but over here there's a millions of images. We definitely won't like to label our data individually. So although we have data over here, and let us see how we can use a certain workflow for labeling it. I will talk about it. But here you can see that there is a lot of image data which is for cars, and we'll be using this for training our neural network. Okay, so coming back, application. Yeah, over here. What we'll do is we'll load this data set into my say workspace, and we will start labeling it. Once we have say loaded our data set, what we are going to do is we are going to break down the data into two parts. The first part is training data and testing data. I hope all of you are aware of the importance of training and testing. I have a question for all of you, because now that you are using or learning deep learning for quite some time, let me just see if I can test one simple hypothesis with this batch. Just give me a second. So I'm using a whiteboard, so that's why I'm on the second screen right now. Okay, good. I have a whiteboard with me. So over here, we will take a case study. Let us say I have my data. Say this is 100% of my data. And if I use this 100% of data completely for training, what will happen? Any guesses? As it is. I mean, I'm just using it for training. Sorry for the spelling. I mean, it is difficult to type with or write with mouse. I would rather use this. Yeah, this is my training data. Okay, if I use it, if it goes wrong, everything goes wrong at implementation. Okay, there is a serious challenge that I added over here. Yeah, we'll get 100% accuracy while testing. Overfit, yes, you will overfit. That's one challenge. Chetna ma'am, you have given you're almost there, but is there any provision for testing that you have kept right now? No, right? I mean, we can say train our neural network and it will use the internal data for say validating it, but then we need to have separate data for testing as well. So a good practice is that we divide our data into two parts. That is, one part is for training and the other part is for testing. What will happen if say I do it 50-50? Any challenges with 50-50 approach that you see? 50% for training, 50% for testing. Underfitting, yes. We are actually losing out a lot of data, right, Vaishali ma'am? We are, say, giving up on a lot of data which could have been used for training a neural network. At validation becomes a problem, yes. Um, so generally, the good approach is say 60-40, 30-70. or 80-20. That is one of the say important aspect of training your neural network. There is also one thing, so training, testing, and validation. So you can also divide your data set into three parts, and as per your application you can decide which one needs to be there, or how much say can be divided, or I can have say this as equivalent portion for testing and validation. So that is also a possibility. You can also think of that. But in this application, we are only doing say um, using 60% of data for training. And how do we do that? We actually say collect or use random data set or data points from our uh, folder over here, this image folder, and all these images will be randomly picked up, or 60% of these images will be randomly picked up for training your data set. Okay, and that's what we are seeing over here. um, any questions so far? Any challenges that you see? All right. So what we are doing here is, I will do it show it pictorially. Um, Here we have our data set. Okay. Let's assume this is a proper rectangle. Um, we are breaking it down into two parts. We are 60% for training and 40% for testing. I would like to demystify one thing for you. Um, so there are three steps that you have: training, testing, and validation. So the data that you use for testing, that testing will also happen while your neural network is getting trained, or say sorry, the validation data will be used when your neural network is getting trained. Let us say I have a neural network whose accuracy is not going below, say above 50% or say 40%. Is there any point, or that too after say four epochs? Okay. Do you think is there any point of training this neural network anymore? So this is my time. Okay. This is my accuracy, and this is epoch one, two, three, and four. So after even four epochs, um, I am not getting an improvement in my say accuracy. Is there any point of keeping on training and waiting for say next 6 to 7 hours or 8 hours, or say even few days for training this neural network? Okay, there is a question. Why 60% any specific? I chosen it randomly, Kranti ma'am. So I mean that's how the application is. I could have chosen more, but over here 60%. It's fine. We can decide that iteratively as a designer over here. There's no I won't say thumb rule in this case, Chetna ma'am, but I would say rather that it depends on application to application what or how much you need. Okay. I randomly took a call of say 60% in this case. I could have had 70% as well. It depends upon me. The thing is, this particular neural network is from MathWorks demo, so they have chosen 60% over here, and this neural network is already trained. We are not training it today, but I would like to tell you that they have already chosen 60%, and that is what we are seeing. But I have a question for all of you. I would like an answer for that. So let us say after even say four or five epochs, if you are not getting any accuracy or improvement in accuracy, is there any point of keeping it training for say next few days or few hours, or 10, 15 hours? I mean, that's a vague timeline, but is there any point of doing it anymore? No. Rather, what would you do? You'd change some training parameters, or training options, like say what kind of algorithm you want, or what should be say um, the step size for your algorithm. All these things. can be decided. That is, you can change the learning rate, and accordingly you will improve your say accuracy. But these decisions can be taken on the basis of whether there is an improvement or not. If you have a very small learning rate, um, uh, your neural network will take a huge amount of time to get trained, but maybe you will have to take a very long time, or huge computation power is required to do that. I mean, that is also one of the challenges. So in order to mitigate this kind of challenges, and to remove that say waiting time, there is a good approach where we also do validation of our training. And validation, what do we do is we try to train our neural network in such a way that if the the accuracy is not improving after certain epochs, we would rather stop the training of our neural network right over there. And there can be a subroutine saying that, okay, if your neural network is not completely trained, it stopped in between, you can receive a mail from your say workstation that, hey, the neural network is not trained, you can come back and change the learning rate or say algorithm, um, or your approach for training your neural network. So that is one of the key things that you can use while training your neural networks at the end of the day. Okay. Have you heard about this kind of phenomena before, or this is the first time you're hearing it? Anyone? I mean, so it's training, validation, and testing. These are the ways in which we can divide our data. Sorry, I went a little off track from my application, but this is an important information that I would like to pass to you, because our main goal is to connect the dots for deep learning to automated driving applications. So that's the reason I was trying to bring it into the picture. Okay, coming back. So oh yeah, what we have done is we have divided our data into say training and testing 60-40 percentage, and that works for us. Um, Now there is one more niche kind of thing that I would like to show you. Um, Imagine a situation where you have to load say hundreds of GBs of data into your system, or say 10-15 GB of your data into your system for training. What will happen if I load say 100 images into my system for training them parallelly, or say thousands of images parallelly if I'm loading it into my system? Anyone? Any guesses? So that I'm going to train my neural network using these images, but right now I am loading them all together into my system. You can also unmute yourself if you want to answer. I mean, this is a chat that is going on. Okay,
It
just a
depends.
generic. Yes, ma'am.
Sorry. It depends on the processing capacity that we have. So, if the processing capacity is there, we can.
Else, your system will
It will slow down.
it will slow down, or we can say hang, collapse. I mean, that's what
Yes.
happens when we try to load too many things into our RAM, right? Um, there can be an alternative approach that we can use over here. We can also try to say take data that the system is capable of handling over here, and only take that much data, do the processing, release that data, and take the next chunk. This sounds good approach, and then let us say if you're doing it using conventional programming language like C, C++, or even Python, that is possible. You can do that, but you have to write certain subroutines for this. In this case, there is an advantage you get, that is using image data stores. And using image data store, what you do is you actually point towards the image where that image is kept. Okay, so what we are doing here is this image data store. I will show you what happens over here. So what it does is it will not take the entire collection of image into your RAM or your memory. It will take individual files into the memory, do the processing, and then release them. But it actually points toward that image and do the operation of getting it as and when required. Okay, so we as a design engineer or a programmer should not worry about capturing or say writing subroutines for doing that. Image data store will do that task for us directly. Okay, I hope everyone understood what is image data store. Everyone understood the advantage of image data store? Yes, I hope so. And then we labeled our data for say training and testing over here. And then what we did is we just tried to say visualize one of these images in such a way that in a bounding box so that we can see where how the say image set that we have looks like. It is taken from our training data. So we have our training data over here. And then what we do is we start thinking about how can we create our neural network for this particular application. So before that, we are just visualizing how our image will look like. Um, there is something important I would like to show you. So over here, we know that in this particular case, the image is or say the car is present at certain location, so you are able to add the bounding box. Okay, here we are not running any deep learning algorithm to do it. It's just that this is how the data is kept over here. um, from and this was taken from say our data set. So this data came from ground truth labeling, and I will teach you how ground truth labeling can be done after I show you how neural networks can be trained. I know I'm going a little off track in such a way that if I draw a timeline, what we generally do is we first do ground truth labeling and then we train our neural network. But first, I would like to show you this workflow so that you will understand the importance of ground truth labeling, because um, this is generally something that we directly capture from or download from existing data set which is available on the internet, and we start training our neural network. So I will first show you this workflow, and then I will teach you how you can generate your own data set and label it properly using ground truth labeler. Okay, so yeah, that's first part, and we understood the position using this ground truth label data already, and we say marked it over here. All right. Um, if I just go with this vehicle data set, which is now taken from my say this mat file, which is already stored in my workspace over here. I would like to show you how this particular thing look like. So I'll just run this file, and here you can see that for all 295 images, we have identified the vehicle positions. Okay, in terms of a bounding box. You can also see that for this particular image, this is the place where the vehicle is present. For this image, this is where the vehicle is present. For this image, there are two vehicles, so they are present at this location and this location. So, are you able to understand how ground truth labeling app gave us a data which we can use eventually for training our neural network? Everyone able to understand this particular part? I know this is a bit tricky, but we have images and we also have positions where the car is present from the mat file that we saw just now. Yes?
So this was auto-generated.
No, it was generated using this ground truth labeling workflow, which I will be showing you after some time.
Okay.
Right now, what we are doing here is we are assuming that we already have a data set, and we will be training our neural network using this existing data set. And this is generally what we do, right, in our day-to-day life. When we start a project, we take some ready-made data to learn something, right? What is the source of data that, or say, source from where you collect your data for training your neural networks? We can also discuss about that. I used to take my data from Kaggle website. There used to be a lot of challenges that fascinated me, and I collected a lot of data for training my neural networks from there. But you can also think of something else. In fact, there was this there is a huge amount of data set for every possible application that you have. I remember we were working on a research project for water quality monitoring where I wanted data set for bacteria images, and also there was a huge amount of data set freely available for bacteria images also. So data set is available for almost every application, or a lot of applications nowadays. So which one do you prefer? Any guesses or say insights on that?
So Major Kaggle,
Kaggle, okay. Yes,
UCI,
all-time favorite. Yeah.
UCI,
Okay.
and KDD Cup.
Okay. Yes. And you say trust that data in such a way that okay, this data will work very good for my project, right? Anyone else who is using some similar website?
So also KDD Nuggets.
Okay. Okay. Have you ever tried capturing your own data and labeling it, ma'am?
Yes, sir. In a competition where we were supposed to identify the plants uh,
Okay.
by taking so we had actually taken field photos, collected it from a lot of our friends all over Maharashtra,
Wow.
and then we did labeling and the actual data set generation.
Okay, that must have been a tedious task for the entire team altogether, right? Yeah. So what we'll do is today we will see how this workflow can be automated in some way where say whatever you're doing so far that is collecting the ready-made data and training your neural network, that is something we'll do. And then I will teach you how we can label our own data using ground truth labeler app. Okay, so coming back, here we already have data which is collected, and now what we are going to do is we'll train our own neural network. And for say some of the applications you can use say pre-existing neural networks over here. There are case studies like say mobilenet ResNet 18 which can be used over here. Let me see if this particular application, no, they are training from scratch. So there is a way in which this existing neural networks uh, can also be modified. So what we do is take something which is trained on say millions of images, and then there will be say some initial layers. So let us think that these are our layers, the slices of our layers over here. Okay, and say for these layers what we do is we just take the features that are trained in some initial layers, and what we do is we just discard the last few layers from a pre-trained neural network. We add our own layers, retrain our neural network in such a way that it is using the features which are detected in that pre-trained network, and how that neural network will be useful for my application. And then this might be giving us around 1,000 classes, and if you only want say a limited number of 10, 15, or say 3 or 4 in our case today, like this is a car, this is a pedestrian, this is a traffic light, and so on. So we can have limited number of classes by changing our softmax layer, and accordingly you will your existing neural network will work for your customized application, and that's the definition of transfer learning. Even that can be attempted. um, in this case we are just trying to use or say give a pre-trained neural network for say extraction of feature, and we'll see how we can use it for our application. But for this say application there is one challenge. There is going to be say a merging from the older neural network to new one in such a way that we have to understand or make sure that the entire thing fits into the older neural network as well. And the input size for the older neural network was around 224 by 224 by 3. So what we will do is we will also make sure that our images that we are going to use for training our neural network will be say automatically um, convert it into the same size so that we can use it for our own application. Okay, so Let us say I have around 200 images over here. Let me see how many images do I have again. 295 images. Am I going to say manually one by one convert the size of this image to 224 by 224 by 3? I mean, is that humanly possible? Not really, right? So what would rather do is we will automate the task as well. And for automating it, what we do is there is a command for transforming the data is taken from training data, which is again um, using data stores mapping to these images over here. So again, we are not loading all of them together. We are just taking in small chunks. And then what we do is we convert these images into the size that we need as per our requirement. Okay, so input size is the size that we are giving, and accordingly, this function will convert the images for us directly. Okay, so that is one of the advantages that you get over here. And what we do is we are say using a pre-trained neural network in this case called ResNet, and over here we are going to modify some of the layers. So we will actually in the feature layer we will actually replace it with activation 40 ReLU, and we will define the number of classes that we have. So from our vehicle dataset library we will take the number of say classes, and accordingly we will say create the object called the neural network that we have, and this will be now trained over here. Okay, so yeah, coming back, so all these options are set to make sure that there won't be any challenges while say getting the data and say modifying our neural networks and so on. Okay, so this is one of the applications of changing the way in which our neural networks are also designed. I will run my code until this point so that I will be able to demonstrate um, how this neural network look like. Okay, so I hope this is being run in the background. The data is loaded. Hmm. So what I'm trying to do now is I will, after this is done, I will show you how this neural network is arranged before I even train it. Okay. So, so by the time this is getting loaded, I will also give description of what is data augmentation. Okay. So let us say I have a limited number of data for training my neural network. If I use say a limited number of images, am I ever going to get a very good neural network which will be able of which will be capable of designing say sorry detecting objects in real time? I mean, do you think with limited number of images we'll be able to do that? Yes, no, maybe. Say I just have 200 images. Is that much amount of data set sufficient for my application? No, really. Okay. All right. The answer is no. Thanks. So, what we would rather do is we will augment the data in such a way that we will be able to um, generate more images from the existing data, and we will use that data for, say, training our neural networks. I would rather show you some fancy thing over here. So, let us say we copy this image into my location. I would like to open this in Paint. Okay, so edit, and I will show you how augmenting an image will work. So for this one, for this car, instead of say using this as it is, I would rather say um, flip this image. Okay, okay, this particular application does not. Okay, so rotate it, or say flip horizontally. Okay, so what will happen here is we are creating a new image or say data using the existing data. I don't know if say share of an image is allowed over here, but say if I rotate it. Of course, that is not possible in say ground truth labeling for a car because of course we don't drive cars inverted fashion. Okay, we would rather drive it in straight way. So rotation does not help us. But say if the image is skewed like this, okay, there is a possibility that you are capturing the photo from a different angle. Still you should be able to understand that hey, this is an image of car. Okay, so you're creating extra data set for identifying or training your neural network at the end of the day. Everyone following me at least answer me yes or no, so I will be able to modulate my session accordingly. So what we are doing over here, are you able to understand what we are doing here with respect to creating more data for training our neural networks? Yes, no, maybe, perhaps. Yes. Okay, good. So this is called as data augmentation, and we are just trying to achieve that goal over here. Um, I will stop. Yeah. Okay. The code is already say the neural network is already downloaded, so we don't need to do it again. Let us just load it as it is. Hmm. So here you can see that the entire task of image data store was done. We will be able to see annotated images right over here. So what I'm trying to do here is I'm actually executing this code. So here you saw how this image was visualized. Now in this case, I will remove this breakpoint and let us see the task of creating your neural network. We are again doing transfer learning. And in this case, we are actually modifying this ResNet, which has an input size of say 224 by 224 by 3. And over here now, an object L graph is created, which is a convolutional neural network, which is created using the data that we have. Okay, so we are just creating a blank neural network. It is not yet trained. We are just doing the background work for that. Um, okay, so let me see. So here you can see the layers of neural network. Okay, can you see this? So we are just changed one of the final layer. Okay, this is a very large neural network, and over here we are just changing one of the say layers which will fit our application. Okay, and if I try to visualize it, let us go to this deep network designer app, and it will automatically identify if there is a neural network in my workspace and tell me how this neural network look like. It's actually a large one, so I'm not sure we'll be able to visualize it properly. But let's see, let's try that. At least we can zoom in to the network to see it. And then I hope all of you have gone through the theory of all this neural network, so I won't be getting into what do you mean by convolution, what do you mean by ReLU, and so on. Do you remember, or is a quick refresher needed to understand what is all these neural networks are, like convolution, ReLU, max pooling? Do you need a refresher for this, or you remember from previous sessions? You can tell me in the chat box. I will be happy to um, talk about it if needed. You remember it? Okay, good. So I would rather jump into the discussion of how this look like. Okay, so now what I'm doing is I'm importing this neural network L graph, which you created just now, which is say the transfer learning application, and over here we can see that okay, this is how this neural network actually look like. Let us say here you can see. So here you can clearly visualize this how this neural network actually look like. And let us say you're doing your research work or you're teaching this subject, because in future there is a high chance that we will be teaching this subject to our students. You will be able to visualize your neural network, show them how this networks are arranged using this kind of tool. In fact, the same tool can be used for say take importing your data and even training the neural network. All these things are available. In fact, you can set the training options for your neural network right over here. What kind of solver you want, what should be say your learning rate, and so on. All these options can be selected right from here, and you can actually use it eventually. No worries. We'll be getting into that discussion in some time. For now, let us come back to our script. Again, one simple question: are you able to follow what I'm trying to tell today? Any challenges? So far, so good. Yes, no, maybe, perhaps, whatever it is. Okay, good. Thanks for the feedback, Kanti ma'am. All right. So what we have done is we have now say brought in this particular neural network or designed this neural network so that we can eventually train it. We also added the features of data augmentation that we will be feeding for our say training of neural network eventually. Um, so here you can see that this data is now modified in such a way that we can feed it inside a neural network. So all this was done at the same time. Okay. Vismita ma'am, can you please unmute yourself and ask the question? I need more data.
Hello, sir.
Yes, yes, ma'am. Please go ahead.
From how you got that
The graph. Are you asking about that bounding box for the car? Okay, good. Yes. So, ma'am, this data about where the car is present right now was already done using labeling app, and we have information about where this box is present. So what we did over here is just that we took the right image, and for this particular image we went to this data set called as say validation data, where the information of this box is present, where exactly this car is located, and accordingly we inserted this shape which is taken from for this image I. We have to draw a rectangle, and the bounding box is taken from where this image, which is say data 2, which came from this location. So this is the size of my image, and this is the position where the bounding box needs to be drawn. Are you able to follow me? So in data 2, this was taken, and this is where we drew this bounding box. So we have not used any deep learning algorithm yet. This is the label data that we have. Okay?
yeah. Okay.
Yeah. Welcome, ma'am. All right, so here we can see an annotated image. Now comes the point of training your neural network. So here you are setting all your options. For this particular demo, I am setting this do training eval and eval as 0, because I am not capable of say training my neural network from scratch today. Of course, if I plan to do it, it might be possible in say half hour or 45 minutes or say 1 hour, because this is a limited number of data that we have. But the point here is that we already have a pre-trained neural network which is kept in this location. Faster our CNN ResNet 50 vehicle example. It is kept in my current folder, which you can see over here. Okay, what I am doing here is for this particular demo, I am just loading it as it is, and I don't care of training it. But if I decide to train it, I would rather start with it just for uh, initialization, so you will be able to see how the things look like. So after I finish this demo, I will come back to the point where I will show you how the training, if training is set to on, how this workflow will look like. But for now, this is the workflow how training can be initialized. And for this instance, because we have limited amount of computation power, we will be just loading it as it is from the previous instance. Okay, so I'm just running it, and here you can see that this particular demo. Okay, wait a second. Am I in the right folder? Yes, I am. Just a second. So let us take the right name because I think the demo name and this name is a bit different. Hmm. Expected can't read file. Have I opened this file? I think so. Yes. So if yeah, I think this file is already opened in the background, so that is the reason we are not able to load it again. Cannot read. Never mind. I can also run this option or say load this file by just say loading this button. All right. I think there is some challenge. Never mind. This is a common error. Maybe because this location is not initialized properly. But the point is that we just load our data set and we will be able to use it for our end application. And once this is done, what we'll do is we will go to our location uh, uh, where this data is kept. We'll just read our data using this data store object, and for this we'll resize the image from our test data, and then we'll try to detect the image where it is kept. Okay, and hmm, all right. I think accidentally I have modified this file when I was downloading it. So that's the challenge. The reason why it is not loading because the name was modified, and that is the reason MATLAB isn't capable of running this file. I need to run this code from beginning, and I will explain you what's going wrong over here. So let us download this file again. Okay, so again it is downloading a pre-trained detector. It will take say 5-10 minutes, uh, uh, which is just that this file is getting downloaded. So it is around 118 MB. With my speed, I should be able to download it in within few seconds. Okay, so yes, the file is getting downloaded. Um, hmm. So I actually kept this prepared for today's session, but accidentally I clicked the hit button and the original output file was modified. But no problem. We will be able to use it. Won't be a big challenge for us. It is downloading, getting downloaded quickly. All right. So let's move on with our demo. I will explain few things around. So hmm. So in this system, you remember that we had this augmentation. So the augmentation was done using various commands called as imwarp. That we were changing the files and accordingly this data was generated. This augmented data was generated for us. Okay. Um, So everyone understood the entire workflow. Any questions on that? The only glitch that happened is that I accidentally um, overwrote my original file. I should have actually taken a backup of that. But never mind, this kind of things happen every day. Yes. Once this file is downloaded, we will be able to see the output. Meanwhile, any questions that you have? Anything you would like to check? I also see if I can download this file directly from the website. It will be much quicker over here. All right. This will take 5 minutes. Never mind. So, anything? Do you want a summary of this discussion, or we can go ahead with the next demo that I have for us? By the time this gets downloaded, and if I see an output that this is loaded, I will be able to move on. So, to summarize it, let's visualize our workflow. Say without any script in our hands. So let us see. What we did is we had some data set with us, and this data set, this images, were around 295. Now 295 images are not really sufficient, but we just got started with this kind of say image set so that we can at least train our neural network using whatever data we have. Then what we did is we also labeled these images using ground truth labeling technique, where we know that exactly that this is the ground truth reality where the car is present at a certain location. So for every image in this 295 images, what we did is we captured the image information using the labeling app, and the location where this car is present at this time is now also given. So for this particular car, we kept the information of all the four corners. So x1, x2, y1, and y2, and the name of the image. Okay. So for our application, this is the data that we have. Now what we did is because these images of were of say not the size that we are working, we used something called as um, image resize, but we did that using transform command, and in between there is one step called as data store, where we gave the path for these images so they can be loaded into a system one by one. Okay, so now that data store is used for capturing this data into our system, or accepting the data into our system one by one. What we did is we transformed all the images using data store and few functions, which will ensure that the size of our neural network, the images is 224 by 224 by 3. This 3 means our color image. Okay, and what we did is we changed the layers in an existing neural network, which is called as ResNet 50. So it is a large neural network of say size of around 185. We just changed few ending layers, and what we did is we inserted our own layer, and then we called this new neural network as L graph. Okay, for this L graph, what we did now is we gave some training options, and with this training options, we trained the neural network. And after training this neural network, sorry for my writing over here. So we trained this neural network, and after we trained it, we were testing it whether it is working correctly or not. And this is the way this application is designed. And that's a quick summary of what we are doing today. Okay, let us see if the images or say neural network is downloaded yet or not. Okay. over here. 118 MB is the size of this image. So I hope this is downloaded in our system. Okay, a few MBs left, and yeah, I hope it will be downloaded. All right. So, any questions that you have before I move on? Anything that you would like to ask? Okay, good. So the downloading is now over. Fortunately, it happened in 5 minutes, which is nice. The time to download is much less than actually say training your neural network. So which is a win-win situation for us. So we also had this previously trained data, which I talked about. So this is the name of the image, and this is the label or the position where this particular car is present, which I told you over here. Okay. Then for this car, we just visualize the first one. Did I run this? Yes, I did run this. Um, Yeah. Now what we did is we created our neural network, which is my L graph, uh, which is created over here. And now we also augmented some data, which is a step that I missed over here. What we did is we had a limited number of data. So we augmented a lot of additional images by sharing the image, that is by pulling it horizontally or by stretching it, so that we create additional data which can be used for training our neural network. Once that is done, so let us do our data augmentation also. So here you can see that you took a mirror of this image, and that was some additional data that you created. And also the same thing was done for the position at which this image was already bounded. So you just apply some mathematical transforms and these things are achieved for you. I hope I ran this particular command. Yeah. And here you can see the images altogether are reshaped. And once this is done, because we have set some options, here you can see that this is set to 0. So we are going to now load the pre-trained neural network, and then we will find the detector. So this is the variable in which our neural network will be present. This entire training was done with NVIDIA Titan GPU with around 12 GB of memory, and it took around 20 minutes for such a powerful machine. So you can imagine how much it will take in the system which does not have a GPU. Okay, so that's how your neural networks, how much time neural networks can take. And believe me, this is one of the best hardware you can get out of over there. So that took around 20 minutes. So imagine how much time my system might take. And now what we do is we just pass our say test image into our neural network using this detect command. And here you can see that the system is capable of detecting the position where the car is kept. Okay. So So we also have to do say testing of our system. So let us say, hmm, so in this case, what you can see is we are able to get a graph for how much precision are we going to get from the system. So let us see that part. So this shows how precise our neural network is and how many times it had to recall. Okay, so in order to improve this accuracy, precision, what we have to do is we have to add more and more data so that you can have more accurate neural network which is trained at the end of the day. Okay, so this is the end of our demo one. I hope you were able to understand the workflow from start to end, at least for image data. Yes, no, maybe. Okay, okay.
Sir, can you show us that part where you said some end layers are to be changed?
Yes, ma'am. I will do that. So in our neural network, what we did is we actually changed some of the last few layers. So what we did is uh, this num classes and feature layer, we just modified these few layers. So in our original neural network, we just changed. So this is my feature extraction network, which is ResNet 50 as it is. What we did is we just changed the feature layer over here, and we also changed the number of classes which needs to be detected. And in our case, it is only one class, okay, which is say the car. And for this, we just changed this to neural network by using this command faster RCNN layers, which did the job for us of changing the graph. So to show you how this two things look different, I will open ResNet 50 and I also see my L graph, and then we'll compare both of them together and see how different they are from each other. Okay.
Yes, sir, that will be great.
Yeah, so let us close this one. And I instead of using this deep network designer, I would rather keep this LGraph layers and ResNet 50 side by side. So my ResNet 50 was kept inside feature extraction network variable. Okay, so DAG network 192. Yes, okay, no, sorry, not this one. Layers, okay, 177 layers. And here you can see that in the end, over here, uh, you have this layer, softmax layers, which is second, yeah, classification output layers, which is giving you around 1,000 classes. Okay, these are the number of classes that you have. But after modifying our neural network, which is my L graph, let us see this. We have layers. In that layer, if I go to my final, say, layer, it is actually not giving me um the classification, but it is just giving me the output as a position where I will be getting some, say, differences. So what I did is I just added an extra layer, a set of layers, which is just giving me a limited number of output. Okay, so here we have only connected output size is 4. Okay, so can you see the differences? So we used our feature extraction
Yes, sir,
layer.
thank you. Yes, sir, it is nice.
Yeah, and we were able to see that in LGraph over here. Okay, so that's one thing. I also promised you something that how can we visualize the differences. Over here, I will push my system to train the neural network. I know this will fail really bad because I don't have the computation power to train it, but I would like to show you how at least the beginning 2 minutes of training look like. Okay, everyone, do you want to see that? Yes, no, maybe you can tell me in the chat box. Yes, okay, let's do that. So what I would do is say do training and eval, okay, equal to true. And say if I now run this, it will enter, sorry, it will enter this loop, and now the option that we have selected will be fed over there. And here you can see, okay, training a faster RCNN object. So the training has started. You can see the busy symbol over here. Um, you just have one class, a vehicle, for which the neural network is now getting trained. And believe me, I have to stop this training in between, not our training, the training of our neural network, just so that we don't waste our time, because we know that our system is not capable of handling such kind of training in the limited number of amount of time that we have over here. Okay. So again, we need powerful computers which are capable of handling this kind of tasks, and we are just getting started with it. So here you can see initialization. We are just getting started. So it said that we are training on single CPU. It is just getting initialized. I don't know how much time it will take. Um, Let us see if there is any update on my screen or not. Okay, good. So here you can see now, these are all the options that you can monitor, and we'll also wait for at least the first epoch to start. So over here, how much time is elapsed? What is the mini batch loss, accuracy, and then you also have other options like base learning rate and so on, which you can monitor throughout the training is in progress. In fact, there are tricks that I used to use when I used to train this kind of neural networks a lot in my previous role. I always took care of one thing that say if the neural network is trained, because I had to keep my system on overnight, I just wrote a simple script over here that if the output is generated, drop me an email, and I used to get an email that hey, your neural network is trained. So then I used to turn on my computer and see how things are. I mean, that's the kind of tricky or say automation that you can do. This is one of the advantages you can take in any programming language that you have. It is possible in MATLAB, it is possible in Python. You just have to figure out the right kind of commands over there. So, of course, as I told you that we won't be able to do our training today using the limited computation capability that I have over here. But at least you saw how this look like, okay? And we'll be using it for our, say, any neural network that you will be training eventually. So I'll stop this training. I know it will be a little tricky. I might have to restart my MATLAB. Let's see. Yeah. Okay, good. Things are in control. So I stopped my training right over here, and that is the reason I this stopped at my first epoch without even finishing my first epoch. Um, no, I don't want to save it. And yes, this is how we can design a complete application for detecting cars using whatever you have learned so far, at least at a very initial level. Okay, I have a 2 minutes break. Let's wait, and then we'll start with the next interesting application that I promised you yesterday. That is, we'll see how lidar data can be visualized, and if there is some script which is available to see how that lidar data can be used for training a neural network. Let's see that. Just give me a second. These are a few commands in MATLAB that is really important. Clearing my variables. Is there anything open in the background? Nothing to be bothered about. Okay. Any question that you have, you can put it in the chat box by the time I'm drinking water. All right. If there's no question, let's move on. Let's see some other nice application that I have kept ready for you. Okay. So, what kind of? I have a question before I move ahead. Um, what kind of output you have obtained from a neural network so far? Um, let us try to visualize it. Okay, so I say that I have an image. Okay, this is the image of a cat. Let us assume that this is a cat. I don't know, I'm already bad at drawing, and I'm now drawing using my mouse. So drawing a cat using mouse. Good. So here I have a cat, and I enter this image in my neural network. um, what is the different kind of output that you will possibly get from this kind of workflow? Anyone? What is the first kind of output that you always get? Anyone? I feed an image of a cat or any image. Okay, boundary, yes. For this particular cat image, I would rather have an output like, hey, your cat is sitting in your image in this position, like a boundary. Okay, class number. Nikat ma'am, we would rather say that we actually tell that, hey, this is a cat. Okay, like the class of or say classify these are the cat. Okay, so that is I think the answer that you wanted to give. Yes, I hope so. Features. So, Kranti ma'am, I would say yes, features is also something that we can use. In fact, this is a very niche answer. Not everyone will be able to understand the answer that you gave just now. So, I will actually elaborate this one. Thanks. You actually brought a very beautiful point, ma'am. So, over here, this neural network can also be used to create data set for my machine learning algorithm. Okay, see, by default, our deep learning algorithms are heavy that require extremely large amount of data to be say to give us some output. But the challenge is that we might not always have huge amount of data for classification, right? Sorry, for training our neural network that will give us the right classification. Sorry for grammatical error over here. So what we can do is we can use an existing pre-trained neural network like say AlexNet or ResNet 50. And what we can do is, this is a neural network, a complete series of say layers that we have. Okay. And what we do is we feed this cat image over here, and we don't expect the output to be predicting that, hey, this is a cat or where the cat is present. We would rather take this output from in between and say that, okay, for a cat image, this is the boundary of how the cat look like. Okay, or this is the color spectrum, or say this is the heat map where if a cat is present over here, this is the feature or say shape in which the cat's face will be looked at, or say this is how the body of a cat look like. And these features which are detected by our neural network can be together captured and fed into a machine learning algorithm which will have a less stringent kind of say or a less computationally heavy detector which will predict that, hey, using these features which are already present with me, I will be able to predict that this is a cat. For a limited kind of application, this is also possible. So everyone understood how getting features as an output is also one of the output that a neural network can produce. And in automotive application, you can think of this like, I know that I have to deploy my algorithm on a microcontroller or say a computationally less powerful embedded device, like say NVIDIA GPU, say Jetson Nano kind of GPU which we have. So in this case, you can also say detect the features of wheels, doors, the structure of a car, and so on, and say these features can be used to train a machine learning algorithm, and then you can actually deploy it on a say less computationally effective device and still run it over there. Okay, everyone able to understand how feature as an output can be used to design a less computationally powerful machine learning algorithm at the end of the day. Everyone understood? Yes, no, maybe, yeah. Have you heard about this kind of application before? This is nice. I was really fascinated to hear it when I heard it for the very first time, and I actually tried it out. But this is a very nice application. You can actually think of it if you're doing some research over here. Um, One more output that is produced by, say, your neural network is, have you heard about semantic segmentation? Anyone? I think you must have. Yes, good. So can anyone who said yes, sorry, I'm not going to put you in a spot over here, but those who said yes, can you try to define what is semantic segmentation? You can unmute yourself. This will be a nice conversation that we are having. And the next demo that I'm about to show you is for semantic segmentation. So um, would you like to try it? Nikahat ma'am, Jayashri ma'am, or Vaishali ma'am?
Dividing, sir, yes. Dividing the image into some meaningful segments, like you identify the, I mean, this part of the image is a person, or this part of the image is a car, or something like that.
Yes. So I would say we are doing it pixel wise, right? So this pixel belong to a car. This pixel belong to a pedestrian. This particular pixel belong to a road. This one belong to a tree. So we do pixel wise segmentation. You correctly mentioned, ma'am. We divide a complete image into small parts, and we are doing it pixel wise, so that we have a complete spectrum of what all those objects are, with a confidence that hey, this particular thing belong to a certain category, and accordingly decisions will be taken. So let us look into some application like that, and here we go. So here we have a application of obtaining a occupancy grid um, using a simple monocular camera, and we'll be doing semantic segmentation on that. I have already demonstrated the workflow for say how neural networks can be trained. I hope I have captured um, just give me a second. If I have not downloaded the, wait a second. Yeah, sorry, there was a glitch at my side. Um, yeah, let me just check if I have downloaded this particular neural network in my system. So change the current folder to semantic segmentation one, and do I have this stored somewhere? Okay, I think I deleted it accidentally. No mind, I'll just show you the workflow, and I won't get into the discussion of um, how this can be say deployed. But yeah, in this neural network, you can actually estimate the free space, which is the road, and only we are focusing on the road. So this is like pixel wise capturing. Okay, what am I doing? Um, I was actually trying to zoom things over here. So this is the, I think, maximum zoom I can get. So here you can see that uh, every pixel is now getting identified, and then you will have a confidence that okay, this is the region in which my car can be driven. Okay, so the reason I zoomed so much is to show you how this segmentation is happening. And there was a very nice application that I designed where, of course, I don't have the hardware with me right now, but I was able to convert this entire algorithm into a very small footprint that was deployed on NVIDIA Jetson board, and you were capable of say running it on a less computationally powerful device without any challenge. So even that is possible. The frames per second was around 5 frames per second for me, which was not sufficient for automotive application, but it was good enough for a college project. So if you're thinking of teaching or letting your students do some research or build some final year project on this, you can also think of deploying this kind of algorithms on Jetson Nano and building a robot with that. So that is a possibility. I'm just telling you at a high level. All right. So for this, what we do is instead of using the same image, I now convert the image into bird's eye view. So what will this look like if I'm capturing the same image from, say, above? So let me draw this. So I have my car over here. Okay, this rectangle is car. Let us assume that this is car. Okay, and then we are say capturing image of our surroundings like this. So the same image that we have using our transformation method, we will try to augment that. Okay, there is a bird's eye view of this car, and this is the information that I have over here, which will be used for navigating in the current zone. Okay, everyone understood how the transformation is working. So the dashcam image that we are having is now converted into bird's eye view using our transform methods, and we will be using that for taking our or doing the operation of uh, navigating on a road. Okay, so coming back for this image, we now know that this is the area in which your car can move freely, and we can navigate in this zone. Okay, so that's how you can start designing your algorithm, and then you have your occupancy grid. So this is the position x and y, and your car is over here, and this is the say front view of your car or the region in which your car is viewing right now. And accordingly, you can take certain decisions whether I'm allowed to go in this zone or not, and this is occupied, I'm not allowed to go into this zone. All this can be say deployed on your hardware directly by using one single image that you have at a given point of time. Okay, everyone able to understand how we moved from a simple image to semantic segmentation, and then a bird's eye view, and then how we can navigate our car. So that is how a simple workflow can be designed using the existing knowledge that we have for this particular vehicle. I mean, always there is not a chance that we'll always have a camera on top of our car like this. I mean, we won't be having a drone running on top of our car. I mean, that's a nice project you can think of. Say a drone sitting on or always flying on your car and capturing or guiding your car, but that's not practically feasible, right? So this is one of the nice applications that you can think of where this kind of navigation can be achieved. Okay. Nice question, Vaishali ma'am. How can we achieve this transformation? So, well, this is the reason why people love MATLAB or say some of them hate it. There is a library which actually help us. So what we do is we just give our image, say that a transform image using bird's eye configuration, and automatically your image will be converted to say bird's eye view. Okay, so this is one of the advantage you get. You can actually use this library, and let me see which tool it belongs to. So this particular command belongs to, I think, image processing toolbox. Let me just open it. Okay, this actually belongs to automated driving toolbox. So if you have access to this toolbox, you can actually build it like this. Okay, so here you had this original image using bird's eye view. I was able to augment this, and then I was able to do the navigation. Okay. Hmm. So this is one simple demo. I have one lidar example also. Yesterday I talked about lidar a lot. I would like to show you how this application look like. So now we're in a different folder. Okay, good. And here, I would like to open this as a live script. Just give me a second. Yeah. Just give me a second. I think I prepared some other demo for live script. Never mind. Let us just run this one. Okay, so we'll now run this system. I hope this might take few seconds, and once it is loaded, you will see that certain data is loaded into a system, and you can see the visualization of a lidar, how it is navigating in a environment. Okay, but again, there is a dependency of downloading some data, which is a heavy data again. Let us see what we can do for this one. Is there some noise? Is there any noise coming from the background from my side? No. Okay, good. All right. So what happens is that there are certain demos that I keep prepared. This one I downloaded the data that was needed, but accidentally I think I overwrote or say lost the data somehow. That is the reason why I'm not able to see it. But okay, good. Here we go. So here you can see that for a car, some radar data was already captured, and then for that particular car, how the data radar data can be visualized. Yeah. Can you see this on this video? It is actually a simulation which is going on in my system. So this is the images that we capture is not the only form of data that you have. There is a very different kind of say data that also can be used for your say application where you can actually use this lidar data for doing the navigation task as well, and then you can decide what is the occupancy grade, which is the say free zone in which your car can be driven. So you just don't have to rely on your image data. Even lidar data can be used for doing the final task. And here you saw that for my car this was the navigation that was done, and we were able to do it just by um, seeing how the car navigated in the region. So this is actually the rectangle that the car created, and automatically we were able to predict that in our map the car moved from one position on another by using this lidar data only. Can you see this? This is also getting navigated. Actually, the code is getting executed right now. But yes, I hope you are able to see this entire thing. Okay, so everyone understood how not only images but also lidar data can be used for applications like this. I would rather stop this simulation. You already saw how lidar data, sensor data can be used. And let me navigate to some examples which are more interesting ones that we can think of. Uh, Unfortunately, I don't have the bandwidth to show you the say workflow for ground truth labeling, but I would rather leave you with this workflow. So there is an app called as ground truth labeling app, and it is used for automotive examples. So here you can actually use an automatic workflow for directly labeling your data. What you do is you start with simple images, and then automatically your for your videos and your images, the labeling app will do it for you. If you see that there is some problem in the detection that is done by this algorithm, you can correct it right over there, and then you can move on. So this is a very nice application, say, which will help you to do the automation of your task for say labeling your data. So if you're designing an automotive application where you have to do ground truth labeling, please try using this in your project. This will be a nice feature addition to save your time at the end. Okay. This is also part of automated driving toolbox, which is something nice you can think of. So here you can see how I can mark my lanes and boundaries and so on. All this stuff can be easily done using say click and paste button over here. Okay. Let me see where I am right now. Okay, let's just. I think the simulation is over. Yeah. So this is the place in which you navigated, and this is the data or say occupancy grid that you have captured. This is the place where you are not allowed to go, and this is the place where you are moving, and you were able to see how the data was captured for navigation inside this path. Okay, so this is kind of a nice application you can think of using your lidar. You actually had a complete say mapping of in which places you are able to move on. Okay, so that's one thing. All right, so we have last 15 minutes. I think I'm almost out of my demos. Any questions that you would like to ask me? Anything that you're curious about? You can ask me right away. By the time I'll see if there is any other demo that I can show you today. Talked about lidar. We talked about uh, deep learning workflow. Um, okay, there is one thing I would like to. I think I forgot to tell. This was regarding this 3D environment in which your vehicles can move. So let me show you how this can be done in Simulink. Okay, yeah, I said I will be doing this today. So mm, good. So let me open this model, which contain the workflow for say capturing the image and then planning a trajectory which can be used for parking your vehicle automatically. I mean, what do you think in India? Is it possible to deploy an autonomous car and you hope that it will run properly right now? I mean, do you see that as a possibility coming in, say, 2, 3 years or 5 years from now? Not really, right? But I would rather tell you that there is a good possibility that although we cannot get into autonomous driving, we can think of that India will be able to get into a zone where we can build ADAS applications. So, which is ADAS means um, say automatic driving assistance system, which will ensure that the driver who has a complete control will have some additional input or data that he or she can use to navigate on a road. Say detection of blind spot, or this is the angle of steering that you need to take in order to go to this certain position, all this can be automated, and that can be a potential product that we can bring in India at this time, using the limited infrastructure that we have. And with infrastructure, I'm not talking about the infrastructure in a car, but the infrastructure on a road, or say in an open in an urban environment. So at least we can have parking lots, or say indoor environments, or say some urban environments where these things are very well regulated, and that can be used for, say, designing some limited level of automation. You remember yesterday I talked about ODD, operational design domain. So we can have a limited number of operational design domain where these cars can be designed, and automated parking valet is one of the examples that you can think of. So I'm just running. I should actually click on the run button earlier. Yeah. So what I'm trying to do here is when I clicked on run, it will be doing the planning action. Accordingly, a trajectory is generated. And yesterday I showed you one-dimensional model. This particular model contain a very complicated vehicle model, which is actually standard to the, or say compliant with the SA standard of 607, I guess. And accordingly, the vehicle is controlled in this case. Okay. All right. Yeah, this is getting loaded, so I will go on a few seconds of pause, give some rest myself. So apart from MATLAB, do you know that what kind of tools are available in this environment right now? So I'm talking about MATLAB right now, but just curious to know if there is some other environment which is available. Okay, so by the time this gets loaded, I will actually share a research paper with you that I am reading from past few days. If let me check if that is the research paper that I want. Uh, yeah. So have you heard about IEEE Access before? Okay, the code is getting executed. Yeah, let us see this. So, so for this path that we have given, we will be able to select uh, the, automatically the trajectory is designed accordingly. Hmm. And we'll see. Okay, wait. And you are able to see that this particular car navigated through the space over here. Okay, coming back to IEEE Access that I was talking about. Instead of MATLAB, let us say you don't have access to MATLAB. There are a lot of driving simulators that you can use and deep learning frameworks which is available. The one which is popular and actually at KPIT we are using heavily is Carla, because even KPIT is one of the contributors to Carla. Let me show you here. And so this is one of the tools that you can also use for, say, designing your system. Just paste this link in your chat box, and you can actually go through the this is freely available. In fact, you can download it immediately and start using it. It's open source tool, which has a lot of layouts like urban layout, buildings, vehicles, and so on. And you can actually start simulating your systems in this kind of environment. And then you can, if you go through this course called as for autonomous driving on Coursera, there's a complete training which even I went through just a few days ago to understand the minor details of how automated driving applications can be designed. Apart from that, there are people who are using games for simulating their say car in a virtual environment, and even that is something people are trying out. So do think of this kind of tools which is readily available. In fact, this GTA 5 is not freely available. It's like an expensive game that you can instead you can purchase MATLAB, or else you can actually go with Carla, which is easy to use. So these kind of environments can be used for testing your autonomous driving algorithms, and along with deep learning uh, 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 say algorithm that you have, and see if how this things are working, and then you can use this information for publishing your papers, doing some good research, and say use whatever you learned so far in some real world scenario. Okay, so that's all from my side. Um any questions or say ending any ending notes that you would like to say before we end this session? So thank you. Thanks. Over to you, sir.
Yes. Participants, anything you want to say? Nothing?
Well, thank you, ma'am. And I will also share some PDF documentation, some nice openly available reading resources for automated driving, and how, say, AI is a big component in that. You can actually read this and understand how this things are implemented in real world. And I should drop an email to sir, say mostly today or tomorrow, and you can start reading that. Thank you.
Thank you, Pawan. Thank you very much. And drop that email as early as possible because I'll put
Sure,
it
sir.
on Moodle because when till our final date is there, probably people will refer it after
Sure,
that.
sir.
We don't
We'll
know.
do that. And
Okay.
say if anyone has any question that you are not able to ask me, you can definitely connect with me on LinkedIn and ask me a question. I will be able to say directly contact you. So yes, there's a question. So can I you have sorry, when we have your contact mail, you can directly connect with me on my LinkedIn profile. Like I'll be directly able to answer your questions over there. So that will be easy for us instead of mail. We know how frequently we read our mail, so it's much easier to communicate with people via the LinkedIn profile. So just putting the link over here, you can connect with me on in LinkedIn. Okay. All right. Over to you, sir. Again.
Okay. Thank you, Pawan. Thank you very much. So you have demonstrated good demonstrations. You have done a lot of case studies. Thanks a lot. And you have shown through MATLAB Simulink all these case studies. So that has again built up a confidence that yes, we can use this kind of tool sets. Thanks for that. And I was actually a little bit worried when we started to design this course that who is going to give the case study of autonomous driving car because I wanted to have that ability. And then I got connected to you, and you immediately agreed. And in spite of your busy schedule from a company, you took out these two complete sessions, evening sessions. Thank you very. I know you have a lot of constraints from your company. Still, you agreed to show all demonstrations and everything. Nicely engaged the participants. Thank you very much for this, and we will get back to you in future as well. So now,
Sure.
whenever there is a data science and its application related some event going on, I'll
Sure.
definitely contact you. Okay, and I hope you will not mind.
Definitely.
Kindly accept this virtual memento, or you call it as a certificate. So kindly
Thanks,
accept
sir.
this.
It's really nice to see this memento, and I remember getting a memento from you since the beginning of my career. This is nice to have it in a virtual mode as well. Thank you, sir.
Thank you very much, and a lot. Thank you very much.
Thanks, everyone.
Don't forget, today is Wednesday, And Wednesday means another milestone for submitting your assessment. So last 3 days, whatever you learned, Monday, Tuesday, and today. So 3 दिन का आपको submit करना है. I hope you are not forgetting that. Okay. Please submit. Don't submit the blank evaluation sheets. We got few blank evaluation submission मतलब वैसा का वैसा उठा के submit कर दिया ऐसे नहीं होना चाहिए. It has to be filled with the data properly. Please submit that. This is the kind of a last evaluation है. इसके बाद तो directly Saturday we are going to have the final examination morning. So please submit that. It is required for us. Okay. And thank you very much. Thanks a lot. Tomorrow morning we will meet again with the Govind sir. Entire day he will be engaging with you. Thank you very much.
Thanks everyone. Bye.
Okay, Pawan. Bye. Have a nice time.